we've got a question here where we need to find the sample size, and we've got a couple of different circumstances, and they do get a little bit tricky. First thing we want to do though is make sure we have the general information right for the question. So it says the probability of winning the game is 0.4. So in all cases, P is going to be 0.4. Therefore, Q will be 0.6. Worth keeping that in mind. We also know that we're looking for the sample size, so N is something we don't know. We're going to define our variables, so X is winning the game. And certainly in any extended response question, I'd suggest that you do that. I think it's a very good idea to make sure you're speaking the same language as the examiner. So what we're looking for part A is the probability that at least once, so they win at least once, so this is the winning at least once, is greater than 0.8. So that's how I'm going to write that. Now remember that we're going to find our threshold, because if we do a greater than on this calculator, we're going to get a whole set of answers, and that's not going to help us. So I'm going to find the threshold and then work from that. So I'm going to say, let's find where the probability of winning at least one game, there should be a 1 in there, equals 0.8. And that's the same as 1 minus the probability of winning no games is 0.8. And therefore I'm looking for where the probability of winning no games becomes 0.2. So now, let's think about what this means. Probability of winning no games means that I have, if the probability of winning a game is 0.4, that is, then the probability of winning no games, that's Q to the power of n equals 0.2. But Q is 0.6, so I'm looking for n where 0.6 to the power of n equals 0.2. So I'll put that into my calculator, and I will write down 0.6n to the power of n, that should be, equals, oh, that's not working, let's try again, 0.6 to the power of n equals 0.2, and I'll solve that. And I know there are lots of different ways to solve it, but this is just the way that a crusty old person like me does. And I end up getting an answer that's really useless, so I'll hit that again, and I get 3.15. So therefore n is 3.15. Now, I can't play 3.15 games, so therefore the probability of this happening is at least 4 games. Because if I only play 3, even although rounding it off to 3 would be closer, if I only play 3, I haven't reached this threshold. So I need to go to the next game, which is 4 games. Now let's do part B. Part B asks that the probability of winning at least twice. So the first thing I want to think about is that the probability of winning at least twice, that's the same as 1 minus the probability of winning no times plus the probability of winning once. So 1 minus the probability of winning at least once. Okay? So therefore, if we find out this and this, then we should be able to find out our answer. Now, the probability that we win no times is P to the 0, which will be 1, times Q to the n. So, therefore, it's 0.6 to the n. Let's just store that in our memory banks for a second. The probability that x equals 1, that we win once, will be nc1 times p to the 1 times q to the n minus 1. So let's put in our values. It'll be n times p, which is 0.4, times 0.6 to the power of n minus 1. So therefore, I need to add these together. To make this work, I need to add these together. And remember, I'm looking for a probability of 0.7. So therefore, what I'm going to write is that 0.7 will equal 1 minus, and then I'm going to sum these two together. 0.6 to the power of n plus 0.4n times 0.6 to the n minus 1. And then I'm going to solve this for n. So I'll write that in. And let's do that on the calculator. So we'll go 1 minus bracket 0.6 to the power of n plus 0.4n times 0.6 to the power of bracket n minus 1. And all that, let's make sure I've got the right number of brackets, all that equals 0.7. So I'm going to highlight all of that, go interactive equation, solve for n, and I'm going to get a value of n equals negative 1. Now, a negative number is not a possibility. I can't have negative trials. So the number I get is n equals 5.322. So I write that down. So n equals 5.322. Now it says the number of games. We can't play 5.3 games, so therefore my answer would be at least 6 games. And there's how we'll solve a question like that and how we'll interpret the answer. And there's the tick and the smiley face from our once-in-a-lifetime happy examiner.